Hey yo, I'm Jacob Buckman. If you listen, you'll find I'm a young experimenter, also dope on the mic. So let me introduce you to what my project is, comparing methods of biometric keystroke analysis. Biometric tells we pull apart from their friends like fingerprints or DNA or iris scans, but I use something found in everyday life. I recognize people based on the way they type, but just saying typing rhythm is pretty generic. I represent it so machines can understand it. I chose to do that in two different ways: dependent variable analysis, accuracy. Duration and latency are the things I tried to test. Duration is the time it takes to get a key pressed. Latency, the time in between adjacent keys. So for my study, I have hypothesized that there would be a difference in accuracy between duration and latency. So finally, I was good to begin my study, so I got a group of my friends and wrote 2 Java apps for data collection. Account creation was the name of the first, and each of my subjects chose a password, entered their passwords 15 times each time in security test once the phase was complete, which let each enter the pass of all others, so each account had 15 real, 15 imposters. From each entry, got both types of data out of it. Then it was time to perform the analysis. Representing gender as a point and end dimensions, one extra dimension for each character the password is. Use the true user's entries as a baseline data set, then plot each point. How close did it get? Use a function called Mahalanomous distance to find how close each point is to the baseline. Check for each of 30 points and get a list of 30 dumps. The smaller each is, the more likely it's a real one. But if it's big digits, then that type is a fake. How to decide if it's small enough to take? If it's under a threshold, we can accept it, but otherwise it's just too big, forget it. But how to decide what the threshold should be? If it's too small, we reject too many, but if it's too big, we accept some liars. To get the perfect threshold, just plot 2 curves. False acceptance, false rejection in the lies. The program does the right thing what percent of the time? The threshold starts at 0, then increases where the curves intersect the values, how frequent. Errors occur. The program gets burned. That intersection is the expected error rate. I found the EER for each subject. For each case, I did 1 minus error to get accuracy. For both duration and latency, I found the mean. Duration average accuracy was 95%, but latency was higher, 97. But a pair of t-tests are no sig diff, so my conclusion, null hypothesis.